Okay, ATP from glucose. So this will start as carbohydrates from dietary sources will be digested and it will turn into glucose. And eventually in glycolysis, it will then become pyruvate. So from glucose will undergo several processes to become pyruvate. Eventually, 2 moles of pyruvate particularly. Okay, and after this stage 1, that pyruvate will then become an acetyl CoA so that it will enter or it could enter the Krebs cycle. So from glucose from the digestion up to the production of pyruvate, that would be step 1 of the carbohydrate metabolism, and then stage 2 or step 2 will become the conversion of acetyl CoA or the formation of acetyl CoA from this pyruvate. Okay, and then the stage 3, from that acetyl CoA, it will now enter the Krebs cycle. And stage 4 will be having all the intermediates be converted to ATP through electron transport chain. Okay, so from here, let's have a recap of the glycolysis. So we have glucose being converted into 2 moles of pyruvate. Okay, so this is the steps. It has 10 steps. However, it could be summarized by having this. So in every one glucose molecule that will undergo glycolysis or that will undergo the carbohydrate metabolism, it will form 2 moles of pyruvate and 2 NADH as well as 2 ATP. So let's all remember that these are, and eventually we have 2 hydrogen ions and 2 water molecules. But we have to focus here on these products because these are necessary for the computation of ATP. Okay? So meron na yung 2 ATP. These 2 NADH will eventually undergo enter electron transport chain so as to be converted to ATP. The 2 pyruvate will undergo the acetyl CoA formation so that it could enter Krebs cycle that could eventually be producing the intermediates necessary for electron transport chain. Okay, now that's step 2. Now we have this again. Let's recap that the phase of pyruvate could be an acetyl CoA in humans. So as a summary, for every pyruvate, we are going to produce an acetyl CoA. But remember that there are 2 pyruvate molecules for every 1 glucose molecule. And meron din tayong NADH. This intermediate NADH could eventually be converted to ATP again in electron transport chain. And this acetyl CoA could enter Krebs cycle for every pyruvate. So if we're talking about 2 molecules of pyruvate, then eventually we are talking about 2 cycles for Krebs cycle because of the 2 acetyl CoA and eventually 2 NADH. Okay, so the stage 3, so this is the Krebs cycle. We have intermediates being produced necessary for ATP production. So for every acetyl CoA, ano ba yung mga kailangan? This is very important. 3 NADH that could be converted to ATP. And then FADH2 could still be converted to ATP. And GTP, which is equivalent to 1 ATP. So these intermediates have to undergo or have to go through electron transport chain so that they could be converted to ATP. Now, as a summary, this is now the ATP being produced for 1 molecule of glucose. So remember, kanina, during glycolysis, the glucose has been converted to 2 moles of pyruvate. And for that glycolysis, we are producing 2 ATP, so that's equivalent to 2 ATP. The 2 NADH will be converted by having an equivalent of 1.5 ATP if this NADH will undergo electron transport chain and oxidative phosphorylation. So that is 2 times 1.5 for a total of 3 ATP. So take note that during glycolysis, a total of 5 ATP will be produced for every 1 mole of glucose. And from that, the pyruvate could enter the stage 2, which is acetyl-CoA formation. Okay, so during this acetyl-CoA formation, the 2-pyruvate will then become 2-acetyl-CoA. And during this conversion, kita natin kanina that a NADH will be produced. And for that, it is equivalent to 2.5 ATP. However, there are two NADH because of the 2-pyruvate. So therefore, during this stage, acetyl-CoA formation, it will be producing 5 ATP as well. Now, on the third stage, which is the Krebs cycle, we all know that in each cycle, it needs an acetyl-CoA. However, since there are two acetyl-CoA molecules, so therefore there would be two Krebs cycle. Okay, so for this Krebs cycle, we know that there are 3 NADH for each cycle, 1 FADH2, and 1 GTP. However, we are putting a multiplier of 2 here because Krebs cycle will occur twice because of the formation of 2-acetyl-CoA, taken that all the pyruvate will be converted to acetyl-CoA. Now, with that said, there are there are two cycles producing 3 NADH2 at 2.5 ATP, so therefore that would be producing 15 ATP. And then we have 1 FADH for each cycle. There are 2 cycles, and eventually with this being converted in electron transport chain and oxidative phosphorylation, the conversion is 1.5, so therefore the total for the 2 cycle is 3 ATP. And the 2 GTP, which is equivalent to 1 ATP, will eventually become 2 ATP. So a total for these 2 Krebs cycle, it will now be producing 20 ATP. Okay? Now, a grand total of 30 ATP per 1 molecule of glucose only. Okay, so 30. Always bear in mind for 1 molecule of glucose, if all this glucose molecule will be converted to 2-pyruvate and the 2-pyruvate will become acetyl-CoA, then therefore the 2-acetyl-CoA will undergo 2 Krebs cycle. They're going to come up with 30 ATP per 1 glucose molecule. So just imagine if you're going to have a disaccharide which is composed of 2 glucose molecules. So therefore, mamumultiply ito ng, this could be multiplied by 2. And imagine if you are dealing with polysaccharide with hundreds or thousands of glucose molecules, then therefore we are talking about a very large number of ATP or a high energy containing molecule. Okay?